Hi everyone, I'm going to do a quick example from section 2.2 question 31 in the Lumen homework. So this was an Excel problem and it says complete all work below using cell referencing formulas shown in the book and classwork. Okay, so it gives us a function here. F of x is equal to 28x raised to the 0.884x. And then it wants us to create this format here. This is the format we've been using to estimate the derivative at any point. So I have across my top here, x, f of x, and then I get a point really close. So I take that x value and I add 0.00001, right? And then I evaluate the function at that point, just very, very close. And then I calculate the average rate of change between these 2 points that are very, very, very close. And that is what we're calling a good estimate for the derivative. So let's go through. So I want to create an input-output table. I want to start my x's at 0.1. I want to end at 2, and I'm going to go in increments of 0.01. So I've already done that here. I use the fill feature, and my table goes all the way down from 0.1 to 2. Pretty long, like 192 columns. All right, so anyway, it goes pretty long. And then this function, we have to be careful because remember when we have an exponent in Excel, we have to make sure that it considers this whole term as the exponent. So some people did not put that exponent in parentheses. So this would be equal to 28 times my x value is in cell A2 raised to, and I've got to put this whole thing in parentheses. Otherwise, it's just going to do this part first and then it's going to multiply it by 2. So order of operations will not be correct. Then using cell referencing, I'm going to take the x value. I'm going to find another x value that's really close. So I just add that really small number. And then all I do is I take my function, 28 times x raised to the 0.884. And I'm just using this column C as my input value now. So I have the same function. It's just that I'm inputting this number that's really close to 0.1. And then lastly, I'm doing the average rate of change between those 2 points. So this is my kind of my y2 minus y1 over x2 minus x1. And so I've got to make sure I put that in parentheses, the numerator and the denominator, so that it evaluates it correctly. All right, so now I'm just going to copy or fill all those down. I can fill those all at the same time. So I select column B, C, D, and E. I'm just going to bring down until I get to the fill handle and I double click. So this is saying when x equals 0.1, f of x equals 22.8432, blah, blah, blah. And this says when x equals 0.1, the derivative is approximately equal to negative 26. Point, blah, blah, blah. All right, so then part 3 says I want to make a graph of the function f of x. And I want to color it blue. So what I want to do is I can, in this case, since I don't have anything down below these columns, I'm just going to select both column A and B. This is my input. I need to tell Excel my input and my output. Otherwise, it's just going to assume my inputs are these numbers, one starting at 1. But that's not the case. We need to tell Excel I'm inputting X and then I output f of x. And so I use insert, and I come down here to scatter plot, and I'm going to use this smooth line graph, and this is my function f of x. And I can just drag this over, and it says make the graph blue. Well, it's kind of already blue, but some people made the background blue. What it wanted was to highlight or select the actual graph, the plot of the graph, and if I do that, if I can go, I'm on a Mac, yours might be slightly different. If I go to format, let me make this wider here. Okay. Okay. I get this format data series. You might also be able to get to it if you go to chart design, and there's some options under chart design here, chart element. But you really want to go to format. And if you're on a Windows PC, you're going to see like a little plus sign here. That's where some of the formatting is. All right, so I selected that whole line, and let's see what I have here. If I click on that paint can, here you can see that this is going to give me the color of the line. That's where I want to go to change the graph color. And now I made it red. All right, but I wanted to make the derivative function red. So let's go back here. I go to the paint can, and let's pick a brighter blue than what I had before. And I'm going to pick that blue color, and I can actually make that wider if I want so that it really stands out. All right, so that is my function of f of x. Let me put that there. Now what I want to do is, it says I want to create a graph of the estimated value. All right, the estimated value of the derivative. So I'm estimating the derivative at these x values. So I'm going to select column A. I have to tell Excel my inputs. If you are on a Windows computer, now you're going to, I don't have my hands on the cursor at all. See, my cursor is moving around. I selected that whole column. If I want to select a column that is not right next to that or non-adjacent, if you're on a Windows, you're going to hold the Control key down and then select the derivative column. If you're on a Mac, you're going to hold the Command key down. And so now you see, now I don't even have my hands on. I just selected column A and column E, and I'm just going to graph the x value and the estimated derivative. That's what I want to graph here. So I'm going to come here, and that is my graph. And let's go back in. I'm going to select that line, and I'm going to change the color of that to be red. That's what it wanted me to graph. And let's make that like a little thicker so we can see what's going on there. All right. Good, so here's my f of x function, and then here's my derivative. So this is saying at each x value, this is graphing what the slope is or the estimated derivative is at each point. All right, so now it says use solver. I'm gonna just slide this over a little bit. It says use solver to find where the estimated derivative has an x-intercept, and then I want to highlight that in blue. So here is my derivative function. The x-intercept means where does it go through the horizontal axis here. So when I have an x-intercept, I'm looking for where my output is 0. So I want to see where is the output or the slope 0. So I'm looking, these are all negative slopes. When I get to here between x equals 0.36 and x equals 0.37, notice that I have a negative and then I have a positive. So I know that somewhere between those two x values it's going to have to go through 0. So I'm going to pick the cell that's closest to 0 right here, and I'm going to use solver. So I'm going to do data, solver. And so what I want to do here, I want to check to make sure that my objective is what cell am I working in right here, cell E29. All right, and what do I want to do with that? I want to force it to be equal to 0. I want to get the x value that gives me a y value of 0. That's the definition of an x-intercept. And where do I want to put the answer? Well, I want to put it right here in the x column. So in A29, and I need to uncheck this box here, and I need to solve. Okay, and this looks good. This is actually a really small number here. It's just scientific notation. So I'm going to make that whole column, that row. Let's go to the Home tab. I'm going to make that blue. And I'm going to make this blue. And in fact, I could format this if I want to. Up here, I'm just going to do, there we go. All right, so when x equals 0.3678, y equals 0, that's my x-intercept there.